Good evening, sir. Am I audible? Am I audible, sir? Hello?
Yes, sir.
Okay. I am sharing my screen, sir, shortly. We'll wait for 1 minute if anyone else is joining. So I hope my screen is visible.
Yes, sir.
So today we'll see how we can go for the injection molding of the component. So this is the drone body which we created in the last session. So within the Fusion 360, there is a module for analyzing the injection molding. So you need to just click on the simulation module. So just click on the workspace and just click on simulation. And inside this, click on the study, new simulation study. And in this case, at the bottom right corner, we have injection molding simulation. Click on that and click on create study. And now we are within the injection molding interface. So here what we need to do is we need to set the material first. So we will be setting the material. By default, it will be generic polypropylene material. So I'm going to select this body as the target body and click on OK. So there is small network issue. To that I am not able to change the material. Just stay with me. I will show you. So these are the various materials available for injection molding analysis. By default, it will be polypropylene, and we have PA66. We have high impact polystyrene, and then we have PAT, TPU. We have PVC. Most of the materials which we generally use for injection molding, all those materials are available. So I am just selecting polypropylene as my material, which is the default one. And then I'll click on close. And after assigning the material, we need to select the aesthetic faces. Aesthetic faces is nothing but the faces of the body which are visible to the user. So generally in injection molding, we want our surface to be as smooth as possible with limited or no defect, no visible defect. So for that I will select these outer faces. So these are the faces for which I want to check or mark it as aesthetic faces. And then we need to select our injection molding location. So the point which you select for injection molding location is the point where the material is going to be injected into the body. So I want the injection point to be at the bottom face of the body. So I will uncheck this and click on a new point. And I want my point to be at the bottom corner like this. And I will delete this point. And I will click on OK. So this is my injection point, which you can see it here. So that is the point where the material is going to be injected into the part. And then we can set the process settings. So the process settings here are going to be my melt temperature and mold surface temperature. So here whatever the recommended range is given, that recommended range we have to enter here. And finally you can click on the solve and click on the solve set study. So as this is going to take some time, I will show you. I have done the same analysis before so that we can see the results. So it will load the results for us. Let's wait for it. So these are the results. Mainly in the injection molding analysis, we will see three different parameters. One is the fill percentage. So how much percentage of our part is being filled by the plastic. So as we can see that the green color one is what is being filled and the yellow color one is one which is not being filled or it is creating one cavity defect. So we can see that approximately 99.9% of the material is properly filling our requirement. So if it is greater than 97 or 98%, then we are good to go. And then we will see the visual defects. So here it is showing that 3 out of 9 aesthetic faces on your model will have visual defects. So visual defect is nothing but you can have any sink marks or anything like that. So as this is not a cosmetic object, so some portion of visual defects we can tolerate. But if it is a component wherein you don't want any visual defects, then you can eliminate the visual defects by uh, injecting the part with multiple bodies by multiple points. So if you inject the plastic from multiple points, you can eliminate the visual defects. So what is being shown in green color are the ones which are satisfying our requirement, and the ones which are in red color will be having some visual defects. And lastly, but the most important part here is also we need to check the warpage. So the warpage is like when the material cools in the mold, it is going to contract. So whenever the material is getting contracted, it is going to create some warpage or deformation. So generally warpage is measured in millimeters. So roughly we are getting around 5 millimeters of warpage, which you can see in the red color. So it is shrinking here from the true geometry. The true geometry is given in gray or black outlines, and the one which is shaded in red color is the deformed shape. So all the four are getting deformed in similar manner. So both the top face and the bottom face will be manufactured in injection molding, and as they are symmetric in nature, we don't have any major issue here. We can go with the manufacturing. So there is actually a dedicated injection molding specialization itself, MTech in plastics or MTech in injection molding. So those engineers will be mainly studying on injection molding, tooling, and those things. So generally the injection molding analysis is done in SolidWorks plastics or Siemens NX plastics, but those softwares are very costly. They are around 9 lakhs to 12 lakhs. But if you have the academic version of Fusion 360, you will be able to do the plastic molding analysis for free of cost, which is the main advantage. And if you know this skill, you can do your various analysis for various big companies at lower cost. You can create your consultancy brochure and offer your services to the clients, which is a good opportunity because we are trying to manufacture most of the things now due to the Make in India and Made in India missions taken by our government. So we are interested in making as much as possible within India instead of buying from outside. And with this overview, I would like to take you to the 3D printing, how you can slice the file for 3D printing, and then I will show you how you can get a quotation for 3D printing as well as injection molding. So I will go back to the design, and then I am going to export this body in STL format. You can right click on the body and say save as mesh, and then you need to select the STL binary here. You will be selecting the STL binary option, and the unit type has to be millimeters. And if you click on OK, it is going to ask you to enter the file name, and I am going to save this file in my downloads. And once the file is downloaded in the downloads, you can start slicing the file. So this is the STL file. You can see the extension being .stl. STL stands for Standard Triangular Language. So we will be using the slicing software. So Creality Studio. So this is one type of a slicer. Depending on the brand and make of your 3D printer, you need to choose the appropriate slicing software. As I'm using Creality, so I will show you in the Creality software. So this is the print bed. So this is the print bed of the 3D printer. So we need to first import our STL file. So in the top menu, you have add. So we will click on add here. And I'm going to select the STL file which we created just now. And here you can see that our part is exceeding our build plate. So if the part is exceeding the build plate, then we need to scale this down. So actually I have selected the Creality under 3 V2. This is our 3D printer. So I need to downsize this by using the scaling option. I will select this body and then I am going to click on scale and I am going to scale this down by 50%. And let me go further and let me scale this down to 40%. And now you can see that our file is created, which is ready for slicing. And these are the various printing parameters. Mainly here we will be setting the layer height. So layer height is the thickness of the first layer. So which will be deposited by our 3D printer. So the recommended first layer height and the layer height is 0.2 millimeters. And another important parameter here is the infill percentage. So I will show you where is our infill percentage. Infill is nothing but how much density you want the material to be deposited. So this is the so here it is saying as sparse infill. Here I can enter my infill percentage. So here I have given 100% infill and internally also I will give a percentage value. So here 100% meaning that all the solid will be printed with the solid material. And now you can click on the slice plate. And after slicing, you can see the individual layers being developed like this. And here we need to generate the supports. So support is nothing but whatever the geometry is there in air, that will be an overhang. So this arm which is present, which is connecting the base of the of the drone body with the motor housing. So the one which is highlighted here is in overhang, that is in the air. So we need to support that. So we will generate a support here. So first layer height is done. Line width, you have to leave it at the default value. So you have to click here make overhangs printable and then maximum overhang printable angle. Here you can give the value of 30 degrees. And now you can see that there is an overhanging material being printed. So here you can see that there is nothing which is hiding or hanging in the air. So with a 30 degrees tolerance, we are able to generate the printing material. And now what you can do is you can click on export G code. So after slicing, the G code will be transferred to the 3D printer. You can give this a name. So here it is saying 1 hour 47 minutes. So that is the total time of the printing time. And here you can see the G code preview. It is saying printing time of 1 hour and 47 minutes. And it is going to consume filament of 21 grams. So here you can also see how much filament material you would require to get it 3D printed. And now you will copy this file into the SD card of the 3D printer or the USB pen drive of the 3D printer, and from there you can 3D print. So there are so many YouTube videos which explain you how to start the 3D printer and how to 3D print it. I will share them. So here mainly you have to select the material. So by default it is PLA. So you can also try with ABS or TPU or PETG. So depending on the material, you have to change the printing temperature. So it will be recommended by the manufacturer how much printing temperature is required. And 3D printer filament. Let me show you how it looks. So this is the 3D printer filament. So this kind of a wire spool will be melted in the 3D printer and it will start depositing the material. So roughly around 1 kg of filament will cost you 1000 rupees. So you need to be careful how much material is being used for 3D printing. And now I will show you how you can get a quotation for 3D printing. So the website name is Mechanica. So their services are in Bangalore. So you have to sign in and create your account on this website. And click on get instant quote. And I will simply sign in with my account. Let me sign in with my account. So after you sign in, this is the dashboard. So you can click on get a quote. And here you can select the FDM 3D printing. So there are various technologies available with them. One is SLA, which is nothing but the stereolithography. and then you have fused deposition modeling, that is FDM, and then you have SLS, that is selective laser sintering. SLS stands for selective laser sintering. And then you have MJF. MJF stands for multi-jet fusion. So SLS and MJF are very costly, but you will get good surface finish and good strength. And then finally you have vacuum casting as well. Vacuum casting is nothing but similar to injection molding, but for smaller quantities. So for the purpose of showing the demo, I will be clicking on FDM, and here you can upload your file. So you can upload your STL file here. I will click my STL file, and you have to select the unit. The unit is millimeters. Click on proceed. So it will take some time to upload the file, and then instantly you will get a price quotation. So here you can see the number of parts, and here you have to select the infill percentage. So here you have to select the material, either PLA or ABS or PETG or TPU. 4 different materials are available. And then infill percentage, here you have to select. So I am going to select as solid. So for solid, they are telling that they are going to charge us 2,800 rupees for this part. So this is one way of getting your instant quotation. And I will also recommend you to check this website called 3Dology. They are based out of Pune. So this is also another good printing service. But the thing is, you need to wait for 1 to 2 days to get a quotation. And while this website is loading, I will also show you. If you want to create a quotation for injection molding, you can go to my quotes and then edit this value, and you can select the vacuum casting. So for this, they have to analyze our part, and they will be preparing a quotation manually for us. So that is the reason it is showing manual quote required. So usually within 1 or 2 days, they will send you the quotation. So vacuum casting is nothing but, so it is like a lost wax casting. So initially they will print the part in stereolithography, and then that one they will use as a pattern to cast it using the polyurethane material. They will create a silicon mold. So I'll just show you what is a silicon mold. So this is one type of a silicon mold. So using the resin, they will create the mold for us, and then they will pour the polyurethane into it. So these are the various components made using silicon molding. So the silicon molding is similar to injection molding, but only thing is you don't need use the metal molds here, you will use silicon mold for it. But whatever the analysis you have done using the Fusion 360 software, that is applicable for vacuum casting or silicon molding as well. And till now, if you have any questions, you can ask. And then I will show you one more demo of how you can get a quotation using geometry. So geometry is a US based company. They are good in providing us mainly injection molded parts. If you don't want to go outside, if you want to get your part printed within India, then you can go for Ravi Plastics. So they are a leading plastic injection molding company based out of Ahmedabad. So you can contact them and send your design file, and they will be able to give the injection molding quotation for you. So mainly I would recommend, as you are developing any new component, you first go with 3D printing, see the defects and test the part, do the material testing, do the functional testing, and once you are finally done with the prototyping part, and once you want to go for mass production, then you can contact any injection molding company. So I'll just brief you about the contents we covered so far. So we have seen the design of drone body, how to export in STP format, how to export in STL format, and how you can standardly use the McMaster-Car or GrabCAD library. And then we have seen the structural analysis of drone frame using Fusion 360. And today we have seen the slicing using slicer for 3D printing. We have seen injection mold, how you can do the mold flow analysis. And then we have seen how to manufacture and list of 3D printing partners from which you can get an online quotation, and what are the materials available. So materials available here are PLA, which is a polylactic acid, and then you have ABS, and then you have PETG. So if you need watertight materials, if you need any component which is submerging in water or being in contact with water, then you can go with PETG. So which is nothing but it is similar to PVC material. And if you want any soft rubber like material, you can go with TPU. Otherwise, you can go with PLA or ABS. So PLA is having more stiffness, but it is brittle in nature. It will suddenly break. Whereas ABS is little bit ductile. So you can simply download the material datasheet. I will share this material datasheet on your emails. You can simply type material datasheet, PLA 3D printing. So this is the material comparison table. So what is the strength of PLA? What is the strength of ABS in megapascals? What is the stiffness? What is durability, and what is the temperature which you can use? So you can compare various materials here. There are so many materials available for 3D printing. So like this, you can also go for carbon fiber or nylon. That is not readily available on Amazon or Flipkart or something like that. But they are mainly available for 3D printing service providers, and they will be able to help you out with printing of any nylon or carbon fiber. And one more thing, one more company is there, that is called as 3D. So 3D Mono is a company which specializes in carbon fiber manufacturing. So they will get your parts 3D printed using carbon fiber. So that is the advantage. But the cost is more, but still mainly if you are testing out any aircraft grade materials or mainly any drone kind of material which you want high strength and lightweight, then you can go with carbon fiber material. So here so mainly it is a composite material, mark forged ONYX. ONYX is a proprietary material which is a combination of nylon and carbon fiber, which is patented by this company called Markforged. So here also you can upload your STL file and request for a quotation by filling out this form. And go to market strategy that we will discuss in tomorrow's class. Like if you want to practically register a manufacturing company and start selling the products, what are the available ways? So what should be the registration process, how you should market your product, and what are the ways in which you can get funding? Those things we will discuss tomorrow. And till now, if you have any questions, you can ask. Do you have any questions? Hello? So that is what I wanted to share for today's class, sir. If there is anything which I missed out, please let me know. And by tomorrow, you will receive your certificate, sir. You can put your questions in the chat box if you have any questions. And as one of the participant was requesting for a detailed video course on ANSYS, so I have to record those videos and then I will share it with you. And I'm actually planning for one dedicated FDP on ANSYS itself, because ANSYS is a very vast topic. So mostly it will be in February. So during that time you can register for the FDP on ANSYS. We will be covering ANSYS Fluent, and we'll be covering also the ANSYS structural. So those things in more detail we will discuss, sir. And I will be sharing some new product development PDF on your email, which you can use for reverse engineering purpose. And like, if you don't have any questions, you can leave the meeting. Anyone having any questions? Or can I close the meeting for today then? So today's meeting is recorded. So I will share the YouTube link after I upload the today's video, today's session. Fine. We can wind up today's session then. Thank you so much for joining. So I am ending the meeting for today. And tomorrow also we will be spending half an hour to 45 minutes on how you can set up your manufacturing company, what are the things needed, and how you can start marketing your product, how you can build a team, how you can get the funding. Those things we will discuss in tomorrow's meeting like tomorrow morning 10:30.